In our labs, we are developing an artificial skin that will allow amputees to recover the sense of touch at their fingertips. Just as phantom limbs can allow people who have lost a limb to keep a vivid sensation of its presence, in a sense we can say that their hand is still wired to the brain, even if it is not there anymore. We use this body memory to trigger the corresponding areas of the patient's residual limb. The different levels of pressure are transmitted to the surface of the residual limb through tiny vibrators of the kind you have in your cell phone. These vibrations are interpreted by the brain of the patient as variable pressure on their phantom fingers. CSEM and partners have developed a brain-spinal interface to re-establish the communication between the motor cortex and lumbar spinal circuits in order to restore the ability to walk after spinal cord injury in non-human primates. This new brain-spine interface uses two wirelessly connected surgical implants. The first, a microelectrode array, is inserted in the motor cortex region, the region of the brain that controls leg movement. Movement information is then transmitted to a stimulator implanted in the monkey's spine, below the point of injury. This implant delivers electrical stimulation at the right location to control movement of the leg muscles and thus enable intended movements. Retinal degenerative diseases are one of the major causes of blindness in humans, but today no clinical treatments are available to treat the condition. Nano Retina, with the help of CSEM, has developed an affordable miniature implant designed to restore vision by replacing the diseased retina with a sophisticated artificial retina. The implant, which converts light into an electrical signal, could give hope to millions. The bioretina is inserted into the eye in a minimally invasive procedure involving local anesthesia. The photovoltaic-powered implant captures the image that is generated by the eye's natural optics and uses the image to generate an electrical stimulation signal. The Wyss Centre is partnering with CSEM to develop new technologies that will enable people to reactivate paralysed limbs through thoughts. When the patient thinks about moving, an implant will transmit this intention wirelessly to a small pacemaker-like device, which is directly connected to an electrode. Restoring communication, mobility and independence is the ultimate goal of the project to overcome the break between the brain and the body caused by traumatic injury.